James St. John. James is an instructor of geology at the Ohio State Newark campus. James has many interests related to geology. He's already spoken to our club on the subject of meteorites. Some of you may remember that talk last year, and then last year he talked about. Welcome, James.
Thank you. All right, good evening. My name is James St. John. Please just call me James. I'm a geologist at the Newark branch of Ohio State University. I'm actually a paleontologist by training. I study fossils, but I'm interested in lots of other things besides that. In recent years, I've been dabbling in and been interested in planetary geology. I'm actually a co-author on a couple of publications on the geology of planet Mercury. But I've also been interested in other things in the solar system. I've given a talk on meteorites for you all before and impact structures, and last year I gave a talk on a field trip to the solar system. So thanks for having me back for a fourth talk. It's a new one. Actually, it's the second time I've given this talk on comets. Do keep in mind that I'm not a comet worker, I'm not a comet researcher. This is a synthesis talk, a summary talk for educational purposes. So all the photos and all the information comes from numerous other sources, printed online, historic and modern researchers, so do keep that in mind. Okay, so welcome everybody, and let's learn a little bit about comets. What are comets? Well, they're fuzzy stars. Stars are points of light in the sky that don't seem to move relative to each other. Planets are points of light that do seem to move relative to the background. Planet means wanderer. And of course there's a missing image there. Comets actually do seem to move relative to the background, and they're kind of fuzzy and they have long tails. Oftentimes they're described as dirty snowballs or icy dirt balls. Some people kind of liken them to deep-fried ice cream. They are small to moderately small, ice-rich bodies. They usually have highly elliptical orbits, meaning they're not going around the sun in a circle, but very ovoid shapes. And occasionally they do get near the sun, and that's when they get extra fuzzy and they develop long tails. The word comet itself means long hair, in reference to the streamers within the tails. Comets appear in the sky without warning. They move relatively quickly. They can last a couple of weeks or a couple of months, and then they just disappear. Sometimes they can actually be bright enough to see in the daytime, and those are quite celebrated. In terms of their movements, here's the apparent path of Comet Hale-Bopp, a very famous one from the mid-90s. And you can see that it wasn't moving very fast here, but then moving fairly fast through the sky, and so forth. Over 6,000 comets have been cataloged over the years. There are estimates, guesses, that there are possibly trillions of them in the far distant solar system. Comets have been observed for as long as human beings have been staring at the sky at night. They've been noticed since antiquity. Lots of ancient early people were looking at these things. Here's an actual 2,100-year-old Chinese piece of literature that has crude stylized drawings of comets and comments on them. Some have 2 or 3 or 4 streamers per tail. 2,000 years ago, a famous ruler named Julius Caesar was murdered in the year 44 BC. And the following ruler, Octavian, who called himself Caesar Augustus when he became head, a couple months after Julius Caesar got murdered, there was a major comet that showed up in the sky. Extremely bright. One of the brightest daytime comets in history. And Octavian actually used the appearance of this comet a couple months after Julius Caesar was murdered for political purposes. He kind of pointed out, hey, there's his soul off in space, off in the sky. He's pointing out that he's rather upset at what happens. So here's the front and the back of a coin that actually depicts a stylized comet. And it's actually called Comet Caesar itself. That right there in Latin means Divine Julius. Some of you may have heard of the Battle of Hastings in 1066. The French invaded Britain. Here is the former British king, King Harold, and here is Halley's Comet going overhead. This is a long tapestry, most of which is cropped off here, but it shows the Battle of Hastings, but also shows people staring at the comet and someone telling the king, hey, this is a sign of bad news, and of course it was. King Harold there lost. Here's a rather ugly illustration from an old book showing Halley's Comet and another comet associated with disease and death and all sorts of horrible stuff. This book here, Danes Buch der Chroniken, or Liber Chronicarum, it's a very famous book. It was published 1 year after Christopher Columbus discovered America. And there's a stylized image of Halley's Comet in it. And if you read the description, it refers to the 684 AD appearance of that particular comet. I have a facsimile of this book in my library. There's actually 4 versions, 2 Latin versions and 2 German versions. 2 of them are colored and 2 of them are black and white. We actually have an original Shedel 1493 book at the Ohio State University Rare Book Library. But you can get a modern facsimile if you want. The same book actually has a depiction of a meteorite impact. So here's a fireball, and here's a meteorite that hit the ground between the European cities of Ensisheim and Battenheim way back in 1492. This particular rock, this meteorite, still exists. People start pounding on it, getting specimens of it the very day it fell. In fact, if you're a meteorite collector, you might actually find specimens of this for sale, sometimes really expensive because it's so historic. Here's an early illustration of a famous comet in 1506. Oftentimes when you hear people talk about comets, they talk about the term great comet. That means one that is extremely visible to the naked eye with a fantastic tail, or maybe even visible during daytime. Here is the Aztec Emperor Montezuma and a comet going overhead in the 1500s. Here's a couple illustrations of some 1600s books showing comets. Some people perceive these drawings right here as being somewhat like a sword. You can see the hilts right here. We grab onto it and the long blade here. You don't know if they really meant that or not, but they liken it to the shapes of swords. Here's an early painting of a comet over the Netherlands. Notice that the tail is slightly curved. Here's Comet Donati in the mid-1800s, and again you have a nicely, strongly curved tail. Okay, so let's take a look at the anatomy of comets. Here's a nice one from 2004. Here's the most famous one in recent history in 1997, Comet Hale-Bopp. Down here is the head of the comet, and at the center is a big old rock, and that's called the nucleus. The nucleus itself, when it gets near the sun, some of the volatile chemicals start turning into gas, and you get this kind of fuzzy halo around it, and that's called the coma. The largest comas have been actually recorded, documented as being larger than the sun itself, which is kind of impressive considering how small the actual rock is. The coma develops when the comet is near the sun sufficiently to warm it up. The ice chemicals in this comet head start volatilizing, and they kind of stick around the nucleus a little bit due to gravity. Now, the comet doesn't have much gravity, so this stuff doesn't get isn't kept close to the nucleus. But basically, this is the atmosphere. It's not like an atmosphere like we have here on Earth. You definitely would die pretty quickly if you tried breathing it. Not much of an atmosphere, but that's what it is. Behind the head of the comet is a very long structure called the tail, and that's what makes these so visually arresting. The tail only develops when the comet is relatively close to the sun, and it always points away from the sun, regardless of which way the comet is moving relative to the sun. If it's going toward it, the comet tail will be behind it. If it's moving away from it, the comet tail will still be away from the sun, in front of the comet as it's going off into the outer solar system again. This tail can be over 3.5 AUs, which is pretty impressive. Astronomical units, 350 million miles long in some cases. It's basically the coma that's been stretched out by solar wind radiation. The morphology and the details of the tail can vary through time. Here's a succession of photos, one day, next day, next day, back in the 1980s when Halley's Comet came by, showing the morphology and the details of this, these tail streams changes fairly quickly. In fact, sometimes perturbations in the solar wind radiation and magnetic field lines can actually sever the tail. We actually do have a couple of sequential photos showing a comet going along, all of a sudden the tail is cut off, like you're taking scissors, and it's just gone. But then it redevelops again fairly quickly. 2 tails for comets are usually visible, unless they're overlapping if you get the wrong angle of seeing the Earth. There are 2 tails. Here's an example of one where the 2 tails are actually overlapping. It just looks like one. However, if you're looking at it from the side, you'll actually see 2 of them. One of them usually fluoresces bluish. That's called the ion tail. Here's a shot of one from the 70s. Here's a shot of one from the 90s. The ion tail is composed of gas atoms, gas molecules. They're electrically charged. The ion tail is going to be basically straight. It goes directly away from the sun. It is aligned with the solar wind radiation and the sun's magnetic field lines. But there's a second tail that goes off in a slightly different direction, and it's usually somewhat curved or strongly curved, and that's called the dust tail. It is light colored, often yellowish. Here you can see the ion tail, and here's the dust tail kind of curving off. Ion tail and dust tail slightly curving off. The dust tail is composed of actual solid particles. Tiny little pieces of mineral, tiny little pieces of rock. Some people liken it to grit. Okay, little dust particles, little rock fragments. So this stuff is actually made of ionized gas, and this stuff is actually made of tiny little solid rock particles. It is slightly to significantly curved versus the ion tail being straight. So there's a color difference and there's an orientation difference. Sometimes you get some very dramatic dust tails. Notice this one here with some fantastic streamers going off. This one, unfortunately, was a southern hemisphere thing. We couldn't have seen it here in the northern hemisphere. The famous Comet from 2007. Now, why is the second tail curved? Because the solar wind radiation doesn't act on these little solid particles the same way as it acts on the ionized gas. So they follow a different trajectory compared to the gases in the ion tail. Sometimes the dust tail can be wide and fan-shaped. So there's the ion tail, and that whole thing right there, that is the dust tail. The color, which is lighter colors, usually kind of yellowish, is a function of it reflecting sunlight. And actually, if you haven't heard about this, you can have a third tail. And I thought about this, what? And actually points toward the sun. It's like, whoa. No? What? Yes, so you get an ion tail, bluish, straight. You get a dust tail, light colored, curved to very curved. And sometimes you get a third tail. So here's the head, and there's that third tail. There's the head, there's the third tail. So the tail goes away from the sun, the third tail goes toward the sun. What? It's actually called the anti-tail, or the anti-tail. Now, it appears to form two ways. Both of them are optical illusions. It doesn't really face the sun. Okay, but when you're seeing the comet nearly head on from Earth or on edge in terms of the orbital plane of the comet, you'll see this extra little structure here called the anti-tail. It's not really pointing to the sun, it's just an illusion, but it is fascinating. There have been lots of famous comets over history. They are nicknamed great comets, the ones that are easily visible to the naked eye, sometimes even during daylight. Let's just pick the ones since 1900. The most famous one is in 1910, Halley's Comet. And actually there's another one, or early 1910, it was a different one. Halley's Comet is certainly the most celebrated comet of them all. Here's a sequence of photos from April to June showing Halley's Comet's tail getting more and more developed and then diminishing through time. So comets appear, they're well developed, and then they disappear. In the mid-1960s, there was the famous comet Kiyoseki, and you get a slightly curved tail, and the streamers are kind of twined, intertwined like braided hair almost. Here are a couple from the 70s, Comet Bennett, there's the ion tail, there's the dust tail, and Comet Kohoutek. That one actually made a lot of people kind of upset. At the time, people were saying, oh, this is going to be the comet of the century. How many times do people say that? And oftentimes it's like a dud. And for a lot of people in the general public, this was a bit of a dud compared to the hype that was generated. And, kind of bitter feelings ever since then have continued to this day. So people are still a little bit cautious about saying, okay, this is going to be the comet of the century. Frankly, we won't know until it actually shows up. But here's a nice image of it regardless. Here's another comet from the 70s, Comet West. This is a famous one because it broke up into several pieces. And this sort of thing has been observed multiple times, not just only in early history, but in modern times too. We now know the comet nucleus is relatively fragile. It easily falls apart. Here's from the 90s, Comet Hyakutake. Fantastic thing. Here's a close-up of the nucleus in the head. You can see the ion tail and the dust tail is directly behind it. So they're overlapping. It doesn't look like you have two tails because you're looking at it on edge. Here's another couple shots of Comet Hyakutake from 1996. The most famous one, we all saw it. We all hooted on over it. I stared at this one in the evening from my condo's back door. Every evening it was out there. Comet Hale-Bopp. Both tails were really obvious. You could see it in the daytime. This is fantastic. and it lasted a long time. The most celebrated great comet in recent history. It was visible for 18 months, which broke the previous record by, like leaps and bounds. The previous record was about half that in terms of its visibility back in the early 1800s. And geez, I want to see this again. Well, you have to wait a while. It won't get back to until the 44th century. In the 2000s, we've had some. Here's Comet Ikea-Zhang. Now, there's a slight hint of greenish-bluish glow around the nucleus. That is real. And it's actually from glowing chemicals. We'll talk about the chemicals that are in comets later on, but some chemicals actually glow kind of an aqua or greenish-bluish color, carbon and CN. So you'll see that sometimes in some images. Comet Magnat 2007, I mentioned that before. This is a southern hemisphere comet, an extremely curved dust tail with fantastic streamer structures within the dust tail itself. One of the most photogenic comets practically ever. Where do these come from? Well, people who have been studying these have found that there's actually two sources of comets. Some come from not far away, and some come from far away. So the ones that don't come from far away are called the short period comets. There seems to be an arbitrary number of about 200 years. If they return every 200 years or less, then they're called short period comets. And that's not strictly arbitrary, although it kind of seems that way. Some of them can return orbit the sun once every 3 years. The orbits are usually prograde. What does that mean? If you're not into astronomy and solar system science, if you take the solar system and look at it from above, so the North Pole of the sun, you're looking down at the North Pole, if the thing is going counterclockwise, most people do digital watches nowadays, there are a lot of people who don't even know what counterclockwise and clockwise means, but counterclockwise going around the sun, that's called prograde. Most comets will do that, not all of them, however. The orbits are usually close to the plane of the ecliptic, the same plane that the planets orbit the sun around. Most of them originate from the Kuiper belt, which is well beyond Pluto. And these things are estimated to last maybe a few 100,000 years before they just run out of volatiles to release. Or they break apart, or they collide into something. Very famous example, Halley's Comet, the most famous comet ever. It reliably shows up every 76 years. Last time was 1986, 2 visits ago in 1910, here's a photo of it. 8 visits ago, here's an old painting showing Halley's Comet and another comet. And here's an illustration of it from the Bayeux Tapestry that depicts the Battle of Hastings in 1066, 13 visits ago. And I mentioned earlier a 1493 book that had this stylized image of Halley's Comet from 18 visits ago. Some comets are coming from very, very, very far away, and they're called long period comets. They have very long duration orbits, hence the term, thousands to tens of thousands to millions of years. So they'll show up, and they won't show up for a very, very, very long time, or they just show up once and that's it. They may only visit the inner solar system once ever in the history of the universe. And some may actually not orbit the sun at all. And these actually come from this way, and this way, and this way, and this way, all sorts of different directions. So people thought, well, okay, these must be coming from a different source than the short period comets. And this led to a very, very interesting idea about the source of these things. First of all, an example, Hale-Bopp is one of these long period comets that came from way, way, way out. This is from a category of comets that come in towards the inner solar system from any direction whatsoever. Another famous example is Comet Lovejoy. Notice there's a slightly greenish or greenish-blue glow around these. Again, that's from carbon-2 and CN. It was hypothesized that the reason they're coming in from any and all directions is that there is a reservoir of comets way, 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 way out there. And someone named it the Oort cloud. There is zero physical evidence for it. The only evidence we have for it is that we have the presence of long period comets. So I would strongly encourage people to emphasize this is a hypothetical concept only. The evidence is long period comets, but we have no visual information about it whatsoever. So what little information we do have about it is there's a lot of estimates, a lot of guesses, a lot of speculation. It's a hypothetical, very, very far away source of long period comets that may form a roughly spherical halo around the solar system. Maybe trillions of floating icebergs out there. Maybe extending from 5,000, maybe 100,000 astronomical units out, really, really far out. Some people speculated that based on what we know about comets, some of these may have formed, or most of them may have formed in the solar system themselves and were tossed way, way, way out there by the gravitational pull of the giant planets. Some comets don't end up orbiting the sun. They just plunge into the sun itself. So here's an image by a spacecraft. They're blocking the sun itself, so it doesn't overwhelm the camera, but that's where the sun is, nothing besides it. These two little things right here are going straight into the sun, never to be seen again. Here's another shot of that sort of thing. Here's a nice comet going right into the sun, and it never came out again. Now, what's really fascinating to me is that we actually can talk about the geology of the rocks nowadays. In the old days, they were just fuzzy stars way out there. You're only looking with binoculars or telescopes or whatever. Now we can actually talk about the geology, the chemistry, the minerals. We can even map the rocks that are at the source of these things. We've had spacecraft visit 6 comet nuclei. The first one is Halo Comet, kind of a fuzzy image, you can still see it. You can see a jet coming out here. You can see some jets coming out of this one as well. These are the 6 that have been visited. The 2 that we know the best about in terms of their chemistry, mineralogy, and structure are these 2 down here. But hopefully we'll have more spacecraft visiting others in the future. What do we know about the rocks that comets really are made of? The nucleus, the core of the head of comets. First of all, they're not round like the moon or Earth or Mercury or Venus or Mars. They're always irregular in shape. Why? Because they don't have enough gravity to make themselves round. Their size is tens of kilometers to maybe a tenth of a kilometer in size. They weigh practically nothing. They have half the density of water. So if you're holding a glass of water, okay, a lot of weight is the glass itself. Okay, half the density of water, that's the density of these things. So some people have likened it to being, comet nuclei are fluffy like cotton candy. And there's a slightly hard crust around them, but on the inside, there's a lot of empty space, a lot of porosity. So these things do not weigh very much. They're low density. Another interesting thing is that these are color photos. Color photos are black and white because there is no color. They have extremely dark colored, organic rich surface crusts. We know that these things are fragile. They have been seen to break up both in historic times and in modern times. Here's a comet. There's the nucleus itself. You see how little fragments it's broken up to all these things? Comet West broke up into lots of little fragments. This famous one here hit Jupiter many years ago. Lots of little fragments. The nuclei are fairly fragile. The best studied one is this one right here. Comet Churyumov-Gerasimenko, also just nicknamed Comet Chury. It's got a very, very distinctive shape. First of all, how big is it? Well, that's how big it is compared to a city. It's about 5 by 4 kilometers in size. You don't like kilometers. That's about 3 miles in the longest axis. It's got 2 lobes. There's one big one there and one big one there. Why? Definitely. The evidence is overwhelming that this is actually a separate comet from this. 2 comets slowly collided long, long ago, perhaps a billion years ago or so. So the people who sent a spaceship here were just thrilled. They got 2 comets for the price of 1. So that's why it's got this very, very distinctive bilobe shape. It goes around the sun once every 6.5 years, but it doesn't get close to the sun than Earth. Its rotation is about 12 to 12.5 hours. When the jetting is going on, it speeds up. If you think about it, that kind of makes sense. Comet Chury has 2 hemispheres. There's a summer and a winter, season-wise. The northern hemisphere has a long, cold summer lasting about 5.5 years. The southern hemisphere has a short, hot summer. Here's a nice shot of it. The northern hemisphere is mostly covered in fine dust, surface, and the southern hemisphere is a mixture of dust as well as surface ice. James, are you sure these are black? These are color photos? Yeah, they're color photos. This is a color photo of something that has no color. And actually, the color itself is blacker than coal. The surface is actually blacker than coal. James, that shouldn't be possible because coal is midnight black. Well, yeah, these things actually are darker than coal. Well, that shouldn't be possible. Okay, look at anthracite coal. It's kind of shiny, like black glass. This is the color of coal, but it doesn't have the luster, so it reflects less light. So it actually has a lower albedo than coal, which is pretty striking. So the dark color absorbs more heat, and that's what leads to volatilization of some of the ices, and that's what gives you the jetting. So yeah, these are color photos, but of just a black and white object. The surface of this thing has a lot of fantastic topography. It's very, very rugged. In terms of porosity, 75% porosity. There's a lot of empty space. Very high porosity, low density. They half a gram per cubic centimeter. Look at all the fantastic surface topography. So people had fun coming up with names. People love to name things. There's a mix of ice and dust and boulders and downright cliffs, sometimes 1 kilometer high, about 0.6 of a mile high. Comets, we now know, are fractal. What does that mean? It means if you have a comet, it's composed of smaller pieces. If you take a look at the smaller pieces, they're composed of smaller pieces. If you take a look at the smaller pieces, they're composed of smaller pieces. No matter how small you go, you still find that these things are made of yet smaller pieces. So, Comet Chury, 1, 2 big pieces. Here is one of the few photos we got of an outcrop on the actual surface. They sent a lander down there, it landed on side, which is unfortunate, but they were able to get some information, some photos. So here's part of the lander, and you can actually see some pebbles sticking out of this outcrop. Now, for those of you who know geology, I'm a geologist, a rock like that with pebbles, what do you call that? A conglomerate. Well, you only call it a conglomerate if you've got rounded pebbles deposited by a stream or something. However, this wasn't deposited by a stream, these little pebbles really aren't that rounded, so we use the term agglomerate for such a structure. And so you got large structures composed of smaller ones, and even on an outcrop scale, you can see that there's even smaller fragments. Sometimes we get fantastic jets. This particular one lasted less than half an hour. What's coming out of here? Well, water vapor and carbon dioxide gas. And where are they coming from? They're coming from subcircular vents. They're kind of similar to sinkholes. They can be wide, they can be narrow. Some actually form because you have a cliff that collapses a little bit. Some last a long time, some don't last very long at all. And these things are kind of analogous to geysers. Now, last year I gave you a talk on the field truth and solar system, and I mentioned geysers, and because I love geysers, but it was also a legitimate reason for mentioning them, because Enceladus has them. But comet jetting is kind of like geysers. What's a geyser? It's a hot spring. It's a hot spring that episodically erupts water and steam. My favorite place on Earth is Yellowstone. I love being in Yellowstone. Whenever I'm not teaching at school, during the summertime, I'm at Yellowstone for as long as my money runs out. I spend about 4 weeks, maybe 5 weeks every summer looking into geysers. Yellowstone in Wyoming has over 1,000 of them. The tallest one in the world, Steamboat Geyser. And this is a shot from the 1960s. When I first started going to Yellowstone, I kept missing it. In 2005, it erupted 2 months before I got there. When I went there in 2013, it erupted 1 week before I got there. In 2014, it erupted about a month after I left. A year ago, well, less than a year ago, in the spring, when I was teaching my National Parks class, this had an eruption. And I told my class, look, nothing personal, but I really don't want to be here. I'd rather be out there watching Steamboat. But it kept going about once a week. I said, oh, good, good, good. Keep teaching, final exams, graded. Get down to Yellowstone. And I finally bagged it. I was content with the fact that I would die before seeing Steamboat. I saw it. I have a half-hour YouTube video where you can see background activity and then the beginning of it, and so forth. So feel free to look that up. Just look up Steamboat Geyser 2018 HD, and it'll be your first hits. The highest spouts have now been measured as over 400 feet high. Now, do keep in mind that what comets are doing isn't quite like this, but it is analogous to this. Comets do not have a water phase or liquid phase. This is the water phase of Steamboat Geyser within a few minutes of it starting. After a variable amount of time, just steam roars out. You can actually hear the sound of steamboats from up to a mile away. It's very, very impressive sights. Now, I'm not an emotional person, but when this went off last June, I started feeling a lump in my throat, started feeling kind of slightly moist eyes. People around me were having all sorts of emotions, and emotions are kind of, they spread around like a cold. And I got a little bit of emotional, but it was a fantastic time. So yes, this is a good way. All right, here's a shot of Comet Chury with an active jet. And here's a more distant shot. Notice that the jetting is rather wide in some cases rather narrow. Here's a cliff collapse event. Here's the same boulder, and here's a crack along the top of this cliff. In July 2015, this is a shot from right before that, this was the condition of the cliff. Right after that, that was, part had detached. So there is actually a dynamic surface that's not just confined to the sinkholes that release jets. Another comment, because we visited, is this one here. Do not say Comet Wild. The gentleman who discovered it, his name is pronounced Vilt, V-I-L-T. It's a common mistake, it's understandable, but please, it's Comet Vilt. Comet Vilt 2. In 04 it was visited, it's about 3 by 4 by 5 kilometers in size. Relatively pristine. It's never been close to the sun before the 1970s. Halley's Comet, however, has gone to the sun hundreds of times. Now, what's interesting about this is it has numerous pits, but look at the shapes. They're not round. Impact craters are round. I gave an impact talk a couple years ago. So these are actually not impact craters. They've got the wrong shape. They've got steep cliffs. Some actually may have overhanging cliffs. And there's some visual evidence to indicate that there might be an undercut arch between two closely situated pits on the nucleus of Comet Vilt 2. There's one depression that actually has a really tall pinnacle, about 100 meters high, at the width of a smokestack. So fairly interesting structures here. There's evidence for landslides. The technical term for that is mass wasting. People have seen piles of debris at the basis of cliffs. At least 23 jets of dust and gas have been seen from this when the spacecraft went close to the sun. It does get actually closer to Earth, closer to the sun than Earth does, just like the other comets. And actually the jets came from the sunlit side as well as the shaded side, which kind of surprised some people. The jets shoot out particles that are made of smaller particles, Comets are fractal. So, the dust, when it gets expelled into space, disaggregates into its little particles. And when they hit the collector of the spacecraft, they also disintegrate into lots and lots of tiny little particles. So, comets are just basically fractal in structure. Here's a photo of the spacecraft's collector, and you see these tiny little dark spots. Those are your samples. Now, we do have equipment for studying those things, but I kind of prefer something that'll fit in the palm of my hand. So this really isn't my specialty, but there are some people who have actually taken these little fragments from a comet and done microscope studies and analysis. Pretty cool. So what do we know about the chemistry and the minerals in these big rocks? This information principally comes from Vilt 2 as well as Comet Chury. Long story short, anything you can think of, it's in there. It's a mix of ice, trapped gases, mineral grains, and rock fragments. If you get rid of the gas and the ice and just focus on the minerals and rock fragments, about 55% minerals, 45% organics, 41% oxygen, 31% carbon, and so forth. Comets, it turns out, based on isotopic analysis, are a mix of solar system stuff, makes sense, stuff from between solar systems, okay, and stuff that predates the solar system. We have some isotopic evidence indicating that there's some fragments from red giant stars from long ago, as well as AGB stars. That is way beyond my specialty. If you want to look those up on your own, that's fine. What kind of minerals do we have? Now, this is my thing. I'm a geologist. Has anyone heard of the gemstone peridot? It's a lime green thing you'll see in jewelry stores. And peridot, the word peridot ends in a T, but please don't say peridot. That is so not. Say peridot, which is so, You're disgracing the dignity of this beautiful gem if you say peridot. Although I have been told that the proper American pronunciation is peridot. Well, I'll go with peridot. But the actual name of the mineral is olivine. So peridot is a gem quality olivine. We have olivine. Now this is actually a fairly common mineral in meteorites from meteorite collectors. We also have a fair amount of pyroxene, also a fair amount of plagioclase feldspar. If you're not a mineral or a rock nerd or geologist, these two minerals are the common things in black lava rock. If you go to Hawaii, black lava rock all over the place called basalt, it's got these two things. Sometimes it'll have this in it too. If you go to Green Sand Beach on the southern side of the island of Hawaii, there's an entire beach rich in this stuff from a lava flow from an old little volcano that had lots of olivine in the black lava rock. It's the only green sand beach in the world. Maybe there's like one other, but it's kind of scrappy. And the ghost crabs that live there, normally they're white, they're green. The beach, that green sand beach there has been so long that they've evolved a green color. There's also fool's gold. If you know your minerals, true fool's gold is iron sulfide, FeS2. But there's a type of fool's gold that's magnetic, which is kind of weird. It's a mineral called pyrrhotite. We have that in comets. There's also a type of fool's gold that has nickel. Now, here's an ore sample from a mine in Sudbury, Ontario. This is a type of fool's gold, and this is a type of fool's gold that has nickel, Ni. That's a type of fool's gold called pentlandite. On top of all that, we also have a mineral called spinel. This is a near gem quality spinel. Notice the double pyramid shape here. Those are called octahedrons. Now, here's the chemistry of spinel. It's kind of complicated. It's an oxide mineral. Long story short, olivine, plagioclase, pyroxene, spinel, those fool's golds, those are high temperature minerals. In other words, they crystallize under high temperature conditions. And what stunned the researchers even more is this mineral right here. If you're not a chemistry nerd, just read that. Tin, titanium nitride. I mean, how often do you hear that chemical? Plus a lot of vanadium impurities. They had to actually look this up because what sort of chemical formula is that? It's a very rare mineral called osbornite. And it was only ever identified in meteorites in the first place. Extremely rare, very high temperature. Okay, so think about this. Comets are snowballs, ice balls with dirt and grit and rock fragments. You've got cold stuff, ice, mixed with high temperature stuff. So what clear is that comets are a mix of materials from cold areas and from the hottest regions of the solar system. It seems like a bit of an odd situation. So those are some of the minerals. What about the chemicals? Lots of chemicals. If you're not a chemistry nerd, then this stuff will go over your head, but I do want to impress you with how many chemicals they've identified. Obviously ice, but 3 kinds of water ice. Have you ever heard of heavy water? Well, the frozen version would be heavy ice. So we have ordinary water ice, the stuff in your refrigerator, your freezer. There's also heavy water ice, and there's also one where you just have one of the hydrogens being heavy. So there's 3 varieties of water ice, plus hydrogen peroxide ice, plus true dry ice, carbon dioxide, plus this nasty toxic gas, carbon monoxide. You're not supposed to breathe that in. We have frozen versions of that. Plus we also have ammonia, that stinky stuff. Plus varieties that have a heavy hydrogen. Okay, check this out. The air you're breathing, 21% of it is oxygen. It keeps you alive. We've got molecular oxygen in comets. Complete surprise. Oh, wow. Nitrogen, okay, 78% of the air you're breathing is nitrogen. It doesn't keep you alive, but it doesn't hurt you, it's just there. We also have stinky sulfur stuff. One thing I like about Yellowstone is smelling the volcano. Have you ever smelled rotten eggs? Hydrogen sulfide, rotten egg smell. Okay, there's a lot of rotten egg H2S gas coming from these hot springs. Now, don't get the impression I like sniffing garbage, because that's not the point. But this stuff here is the smell of a volcano. I love the smell of a volcano. My mom has a photo of me in Yellowstone several years ago, just standing there smelling this rotten egg smell. It's an interesting smell. So there's various sulfur and stinky chemicals, including hydrogen sulfide itself, plus a whole bunch of other ones. And some poisonous stuff. Look at these. Cyanide and cyanide-like chemicals. So there's going to be some nasty stuff in comets. Here's a photo that was recently given to me by your club president. Here's the Pleiades. Here is a green fuzzy comet. Why is that glowing? Well, it's one of those cyanide-like chemicals. So that's pretty cool. Here's a close-up of it taken from a telescope in Hawaii. There's a slightly greenish color from glowing C2 and CN, a cyanide-like chemical. There's a lot of alcohol. It's alcohol, man. Okay, well, wait, chill, slow down. Okay, not all of these you should get excited about. For example, if you drink the wood alcohol, that's the stuff that makes you blind, and you never get it back. Okay, but this is the type that, yeah, people do drink. So, you've got various kinds of alcohols. Methanol, don't drink that. Ethanol, that's the stuff that is in booze. And propanol, butanol, pentanol. These things are naturally occurring in comets. I used to work as an oil geologist. Petroleum refers to rock oil. If the stuff comes out of the ground as liquid, it's called crude oil. The stuff that comes out is in a gaseous form, it's called natural gas. Here's a natural gas flare in Perry County, Ohio, from several years ago. We have natural petroleum gases. The simplest one is methane. We also have ethane, propane, butane, pentane, hexane, heptane, and even probably octane. We have natural petroleum gases in comets. And acids, the stuff that makes you dissolve. Formic acid, vinegar in the form of acetic acid, benzoic acid, and these nasty ones. Hydrobromic, hydrochloric, hydrofluoric. Hydrochloric is really nasty, but we use it in geology classes all the time in dilute form because certain minerals and rocks will bubble in acid, and my students like to make the rocks bubble. The old joke in geology is there's 2 types of rocks, fizzers and non-fizzers. Things that fizz in acid and things that don't. So what we use in geology lab is hydrochloric acid. Oh, this one here. Do not mess around with this. HF, the nastiest acid in the universe. Please do not look up images of HF acid burns. They're disturbing. People can die from this. Just a little bit of this stuff on your skin is enough to kill you, and it happens semi-regularly. Yeah, it soaks your skin. It slowly dissolves your bones. The fluorine combines with calcium in the form of electrolytes in your body to form CaF2 precipitate in your body. If you don't know your mineral, CaF2 is a mineral called fluorite. It's often purple. James, what are you talking about? If you have enough of this spilled on you, you slowly crystallize to fluorite from the inside out. And you die. And there's nothing you can do about it. Now, if that happens to you, don't be offended if people at the hospital watch you with fascination, because this is a rare thing and doctors and nurses like to watch unusual things. So don't take it personally as you slowly crystallize to fluorite. On top of all that, we also got noble gases, things like argon, krypton, and xenon. There's 9 natural xenons known, 7 of which have been detected in comets. And we can actually use this information to infer something about the history and the origin of our own planet. Researchers concluded that 22% of the xenon in Earth's atmosphere came from comets. What does that imply? Lots and lots of comets were impacting the early Earth. They do occasionally nowadays as well, but they did a lot in the old days. And this is the tip of the iceberg. Okay, I can't keep going through these, so here's all the other ones. Benzene is a fairly nasty one. Acetylene is in acetylene torches. An amino acid. A building block of life. Amino acids are the building blocks of life. We have a naturally occurring amino acid detected in comets. That is pretty cool. Formaldehyde. That's the stuff you traditionally use to pickle specimens in biology. Fairly toxic. They don't use it much anymore. I love rare rocks. I love collecting things, fossils, minerals, rocks, you name it. If I can't collect them, I purchase them. When someone tells me about a new rare rock that I can't have because there's only one, oh. And so when I was putting together this talk, I found out that there's been one rock on Earth that we can actually touch and look at that may actually be from a comet. The evidence suggests it is. And there's only one of them. So there's no way I can ever, get my own. Unless I'm lucky or something. This rock is named Hypatia. One rock only. It's found in southwestern Egypt. It's black. Very, very hard because it's diamond rich. It's very, very shiny. Even low quality diamond rich rocks have a nice shine in them. It's very distinctive. It was found in the same part of Africa where this kind of tektite occurs. A very famous yellowish glassy tektite from an ancient impact almost 30 million years ago in Egypt. King Tut's tomb actually had some of these used as gemstones. But this in here, that's not a tektite, that's not an impact glass. This actually may be from the comet itself. This particular event did not form an impact crater. The thing came in and exploded in the air. It's called an air burst. But it fused a lot of sand in that part of the world, and this actually may be a chunk of the actual impactor. And it's not a meteorite. It's probably from a comet. So to finish up the talk, let's talk about comets. Comets have definitely arrived on Earth in the geologic past. For a long time, they've been suspected to be a major, or at least a significant source of Earth's water. What happens when you melt snow and ice? Where do you get water? Earth has a lot of water. Put 2 and 2 together. So here's the Atlantic Ocean, the Pacific Ocean, second and biggest ocean basins in the world. There's been a problem with this. If you look at the chemistry of ocean water and the chemistry of the ice in comets, they don't match. Oops. But it was such a wonderful idea that made sense. Well, the chemistry doesn't lie. So people have been saying, okay, maybe we got to start thinking about something else. However, it turns out at least one, and now more than one, comet has been found that does have the same chemistry as Earth water. So if you think about it, that makes sense. Comets vary in their chemical details. So yeah, we've gone back to thinking that, yeah, maybe comets are contributing a fair amount of water. On the other hand, a recent calculation showed maybe only 1 to 2% of all Earth's water is actually delivered by comets. But that's still a lot. 10 to the 19th power kilograms of water estimated, maybe 10 to the 17th power kilograms of organic chemicals. And we already know that about 22% of Earth's xenon in the air is actually from comets as well. Okay, so what happens when a comet hits Earth? Well, one may have happened in Egypt, but it was an air burst. One may have happened over Siberia, but that was also an airburst. It did not hit the ground. It was not an impact crater. There's the famous 1908 Tunguska event. Something large from outer space went over Siberia, exploded in the air, did not hit the ground, but over 750 square miles of forest flattened. That's kind of analogous to what Mount St. Helens did in 1980. Big sideways eruption, over 200 square miles of forest flattened. However, this was from an exploding object from outer space. The Tunguska event. We actually do have some extraterrestrial dust samples collected from trees in this area. And some people say, oh, they're from meteorites. Some people say, oh, they're from comets. So the jury's still out. But most people think it's possibly an air-bursting comet. We know that comets hit other bodies. This is a famous one from a couple decades ago. There's a comet that broke apart into numerous fragments. Here's a shot of 19 of them. The famous Shoemaker-Levy 9 comet. And it hit Jupiter. And the explosions were bigger than the size of Earth. So this was really fascinating for a lot of people. A couple of years later, people noticed that the rings, Jupiter has very thin rings, were rippled as a result of this particular event. So they're not just flat, like a disk, they're actually rippled as a result of this impact event. And it was still seen 2 years after. Saturn, the same way. Cassini happened to see when the sun's illuminating the rings, right edge on, that it wasn't flat like a disk, it was actually ridged, like that. And people took a look at this and said, those ripples, they were formed during an impact between Saturn and a disrupted comet. And we're still seeing them rippled decades later. They calculated that back in 1983, there was an impact between Saturn and a disrupted comet. Well, James, can't we just go back and check? Because surely we were looking out there at that time. Yeah, no. Saturn was on the opposite side of the sun from us at that time. So we can't go back and check and see that happen. So it happened when we could have seen it. But decades later, these rings are still ridged. Why are they ridged? Why are they coordinated like this? This is what the rings do as they're trying to go back to equilibrium, going back to flat. So here's some computer models showing what would have happened between the impact itself and nowadays. Well, James, this is all cool. I want to go see a comet. Well, it's possible you might go see one now, but even if you don't, and if there are clouds in the way, if you've seen ordinary shooting stars, meteors, most of them are burning up dust-sized particles, pebble-sized particles derived from comets. Yeah, it's not quite the same thing because it's gone. Whereas a comet, hey, you just stare at it, but these things are actually a result of comets as well. Some things that burn up through the atmosphere are called fireballs, are actually larger rocks, but a lot of these things are actually material derived from comets. Questions? Yes?
Well, you told us explicitly Comet built. Well, you kept saying Comet Halley. Everybody makes that mistake because of Bill Haley and his comets.
Okay.
The real pronunciation is supposed to be Halley.
Pronunciation is a funny thing. For example, if you go to the city in northern Alaska called Prudhoe, if you look at the pronunciation of the gentleman it's named after, it's Prudhoe, but all the people there pronounce it Prudhoe. Another example, in Newfoundland, Canada, people make fun of folks who pronounce it Newfoundland. The people who live there pronounce it that way. In terms of Latin, some people will say, oh, there's a proper way to pronounce Latin, but it's a dead language, and if it's dead, there is no proper way because no one actually speaks it. So, yes, there might be more than one way of pronouncing them, but there's variation in pronunciations. So, question?
Yeah, is there any ability to look at the mix of carbon 12 and carbon 13? Is there any physical samples that that's been looked at?
Well, the one that visited VILT 2 did actually have samples, and I'm sure they did isotopic analysis. The details aren't in my head right now, though. Anything else? Yes?
What was that sample called again that was found in the desert?
Hypatia.
Hypatia.
That's the nickname for a rock in the Egyptian desert. Hypatia.
I'll try to spell that later.
Well, it's not too far away. I'll just back up. There it is. I've only seen this black and white photo, so I assume a color photo is just similarly just dark.
What are the
color.
arrows for?
Those are from the original publication, and I don't remember what the caption said. Anything else? Questions, comments? Yes, what's up?
Yeah, I have read that there is a possibility that the Tunguska event was a piece of Encke's comet.
I haven't heard that. I do know that there is a very, very long list of hypotheses about what the Tunguska event was caused by, similar to the long list of hypotheses for the origin of the moon. The safest thing to say is we don't really know. I haven't heard that particular one, though. Anything else?
Well, this may be.
Yes, what's up?
This may be a comet thing as well. I was in college when Comet Yakutake was around. The tail was so long it took up about a third of the sky from the suburbs. Well, again, a matter of pronunciation, this Japanese college student, she told me it's pronounced Yakutake.
The number one
She
most
was
common.
Japanese herself, so.
Well, the number one most common family name in China is Chang. I have asked numerous Chinese how it's pronounced, and every single one of them always gives me a different answer. Chang, Zhang, San. So pronunciation varies, is all I can say. For example, my own name, James St. John, sometimes I pronounce it with the emphasis on the middle, sometimes on the end. James St. John, James St. John. So even I vary the pronunciation of my own name. People often say Hiroshima in Japan in terms of military history. Some people say Hiroshima.
Yeah.
I prefer the first one. A lot of people say the second one, but there's just variations. Question back here.
The Tunguska event in 1918?
1908.
1908? If it was a comet, did anybody see it before it blew up?
Yes.
There aren't many people living in that part of the world, but there were witnesses. It took a long time to get their stories out, but yes, there are. There are quite a few. Thankfully, this wasn't a populated area. What's kind of interesting, for those of you who are interested in catastrophes and disasters, imagine a Tunguska type event over London, or Madrid, or Rome, or Beijing, or DC, or some major populated
Did
area
everybody see it
nowadays.
like a month before, or, you know?
Oh, the comet.
That soon, I don't know. I mean, the actual event itself was witnessed. In terms of seeing it beforehand, I haven't heard that. But I'm not an expert on that.
And there was
on the
a
history of it.
Soviet scientist by the name of Kulik, L.A. Kulik, who went there. And even though it took place in Russia, it took them 19 years to actually get an expedition to go that far because it's in the middle of
I don't
nowhere.
mean visually touched, I
Yeah.
mean, did they see it in the sky before it got to
It
Earth?
was probably just a small piece because it happened. The reason why they think it's the sample of Comet Encke is because it happened during the point in time where the meteor shower that Comet Encke produces was taking place. So it was probably just a big chunk of meteor shower.
Okay.
Well, there's a couple of here.
Question over here.
Yeah, a few years ago, there was a similar event in Russia again.
Yes.
So visible.
Yes.
And another one is, about 5 years ago, we had 4 comets in the morning sky, and I was able to observe them. One of them was named ISON or ISON,
Right.
and it orbited the sun, and it got all burnt out. Totally.
Yes.
It petered out.
Yes. The ultimate fate for comets. Some people think that many near-Earth asteroids are actually "quote-unquote" extinct comets. People have speculated that that extraterrestrial object that went by a while ago was a comet, although they've gone back on that. They have gone back on that, so it probably is not.
Let's take maybe one more question, and then you can talk to James afterwards. if he has-
Is there a question here?
Yeah, could anything be done about a comet headed toward the Earth?
No.
I hate when that happens.
Most of us can barely balance our checkbooks. There's no way we can do that. It's fun to speculate, and people in charge have to pretend to care and do something, but practically, logistically, no. There's some things we have zero control over.
Okay, before I thank our guest, I forgot to mention, Joe Zaleski brought some books on the back table that are free. So on your way out, please help yourself if those are something that you'd like to add to your library. Thank you, Joe. And then, James, thank you very much.
Thank you.